everyone, I'm Alex Crease here at MARKFORGED, and today I'm going to be talking with you about the different methods of 3D printing composites like carbon fiber, fiberglass, and Kevlar. When people talk about composites in 3D printing, it can take two forms, chopped fiber or continuous fiber 3D printing. It all starts with a strand of fiber like this one. Fibers like carbon fiber are so valuable in engineering because of their strength to weight ratio, specifically when applied in tension. Alone, they sort of behave like raw spaghetti. You can easily break a piece of spaghetti by bending it, by compressing it, or by shearing it. But it takes a lot more force to break a strand of spaghetti in tension by pulling on it, and that's how fibers are most often used in composites. When you bond these fibers with a matrix material to help them take shape, they form incredibly lightweight, strong structures because the fibers can be laid out in these optimal patterns that make use of their tensile strength properties. So chopped fibers in 3D printing are a bit different, referring to small bits of carbon fiber broken up and mixed into a thermoplastic like ABS, PLA, or nylon. This gets extruded into a spool, which can then get 3D printed with a deposition-based printer, but doesn't leverage the continuous strength of those fibers. So it's sort of like a booster pack for standard 3D printing thermoplastics. It bumps up some of the material properties like heat resistance, strength, and stiffness, and may improve the print quality and dimensional stability as well. But the strength is largely defined by what's holding it all together, which is the thermoplastic. Continuous fiber printing is a variant of a deposition-based printing process called continuous fiber fabrication, or CFF. One nozzle builds a thermoplastic matrix material while continuous strands of fiber are ironed down into the part with a second. Software allows you to lay these fibers down in specific places with specific settings to optimize the part for its strength, just like with traditional composites. So a part reinforced with continuous fiber leverages the strength of the continuous strands themselves rather than relying on the thermoplastic for strength. And we can show what a difference that makes right here. So chopped fibers are basically a bunch of little pieces of a strong material adhered together in some way, like how these bricks are held together by their connection points. A continuous fiber takes that same material but forms a continuous connection across the loading surfaces of the same part, represented by these plates on the top and bottom. So when we apply a load to a chopped fiber part, it breaks at the connection points, which, when applied to printing composites, is just the thermoplastic holding it all together. When we apply this same load to a part with continuous segments spanning the load paths, in this case the top and bottom plates of the part, the chopped segments act as a filler or a matrix material, and the load holds because it's being distributed across the loading surfaces by the continuous reinforcement. This concept is what makes the continuous fiber so much more powerful than chopped. I hope this clarified some of your questions about 3D printing composites. Happy printing.